Good afternoon. Thank you for attending a 5:30 session. Our topic today is architecting Microsoft applications with VMware on AWS Cloud. My name is Bill Jacoby, Senior Solutions Architect at Amazon Web Services. I've been with Amazon for 4 years, and previously I worked for Microsoft for over 10 years. So I feel good about this topic, and we have a lot of great information to cover. So I'm going to talk about a number of topics here. The talk today will be broken up into 4 pieces. Launching VMware Cloud on AWS Software-Defined Data Center Cluster, sort of what's involved, and I'll talk about sort of the basics. There's a session called ENT305, if you want to have a full hour session on nothing but the internals of VMware Cloud on AWS. So I'm not the guy to go into the depth of how NSX works, for example, but plenty for knowing how to run Microsoft apps. We'll talk about what it means to run in a hybrid ecosystem, how to connect up VMware Cloud on AWS with Amazon Web Services, and I'll go through an example. I could have gone through any of the Microsoft servers, but I think SharePoint, because it uses Active Directory, SQL Server, and is a large, complex server in its own right, is a good example. And I'll at the end I'll take you through a demo of the whole thing. Okay, so the first big piece of my talk here is just essentially what is VMware Cloud on AWS. And VMware Cloud on AWS consists of really three big buckets of functionality. What you see in the middle: vSphere, vSAN, and NXX. So vSphere is the basic virtualization platform with support for ESXi virtual machines, and it's what all of you who are running VMware on premises are currently using. vSAN is VMware's storage environment. I'll talk a little bit about how we've implemented vSAN in the VMware Cloud on AWS offering. And NSX, of course, is the software-defined networking portion from VMware that we have running on AWS. Now, in the case of VMware Cloud, all of it runs on top of AWS Global Infrastructure. So if you look on the left, this represents the customer data center, and I'll talk a bit about how we link to the customer data center. And what's interesting about this architecture is that the customer data center and VMware Cloud on AWS are both managed by vCenter. And so you have a single management interface that represents both the virtual machines and the hosts that are running on AWS. AWS just looks like another site to vCenter, and that site is listed and portrayed as a peer to the sites that you have running on premises or in multiple data centers in your corporation. Okay, you can run on top of VMware Cloud on AWS. You can run the usual management tools if you use vRealize or PowerCLI. All of those automation and programming technologies continue to work because this half of the diagram is VMware and is coded and developed by VMware. Now, if we extend the AWS Global Infrastructure on the right, what we've done with VMware Cloud is we've attached VMware Cloud in our data centers to the traditional services that you think of on Amazon Web Services, so EC2, S3, Dynamo, et cetera, et cetera. And what we've done is we provide a VPC. You'll see this in sort of detail in just a second, but we provide a VPC that represents the blue portion, and the VMware technologies run inside their own VPC, kind of as a way to represent the networking infrastructure or underlying networking. And on the AWS side, we run, of course, in a VPC. So let's peel the onion back a layer. And if you want to launch a VMware Cloud on an Amazon Web Services software-defined data center cluster, you would start off with your same data center on the left. If you're not running NSX, it doesn't matter. It doesn't matter. You can add an NSX Edge Services appliance, and that will allow you to connect VMware. And without NSX, no problem. This Edge appliance is something that will attach to your environment, or I should say VMware will attach to your environment. And that'll extend VMware Cloud on AWS environment to your corporate data center. Okay, and the next thing is, okay, if we want to connect to VMware Cloud on AWS, we're going to connect to a VMware Cloud VPC. And what I'm showing you here is essentially the whole cloud auto-provisioned for you and configured for you at launch as a single tenant. We provide a minimum of 4 hosts. Those hosts can run a large number of virtual machines, but those 4 hosts or greater are provided to you as single tenant hosts. So when you run on the VMware Cloud side of this offering, you're running entirely on your own hardware, on hardware provisioned for you. Okay, it is owned and operated by VMware. The servers, NSX, vSAN, and ESXi are all managed by VMware. Okay. Now to sort of take this a step further, if we want to add the Amazon side of this equation, we ask that you either bring your own VPC to this architecture, or if you're a new customer to Amazon, that you create an account and you provision your own VPC. And then the next thing we'll do is we'll connect these 2 VPCs. And again, that can be through a new account or an existing account. Okay, so the next question is, well, how do we connect this Siamese pair twins on the right? How do we connect the VMware Cloud on AWS side with your customer data center on premises? And the answer to that is we establish private connectivity using what you're probably used to on the AWS side. We use Direct Connect, and we'll connect that NSX Edge appliance through Direct Connect and through a private VIF, which will connect you to the private services on the AWS side. I'll talk about accessing public services like S3 and DynamoDB, and I'll also talk about internet connectivity from both halves in a little bit. Okay, so at this point we've linked VMware Cloud VPC and the customer VPC. We call the diagram on the right the VMware Cloud VPC, and we call the piece in the middle the Amazon customer VPC. So in terms of terminology, that piece in the middle is the customer VPC. And we do the linkage with what we call a VMware Cloud ENI, Elastic Network Interface. And so this Elastic Network Interface, we've had ENIs for many years in AWS. And what we're doing is we're using a VMware Cloud ENI, which allows sort of 2 ends of an ENI that span accounts, that span the VMware account and the VMware VPC with the Amazon account and the Amazon VPC. We have an ENI that lives in both worlds, and that becomes the basis for interconnectivity between VMware Cloud and the AWS customer VPC. So, so we talk about connecting the Amazon customer side with the VMware side using VPC endpoints, whose technical implementation is through ENIs. Okay, and I've now added in to the diagram your EC2 instances, as well as managed services that are inside of your VPC. And we also have a VPC endpoint for things like Amazon S3. So if you look at the bottom of the middle diagram, that represents a VPC endpoint for S3 or a VPC endpoint for the other services that for which we provide VPC connectivity through an endpoint. Okay, and so this diagram gives you essentially the whole picture of the customer data center on the left, connecting using the NSX Edge appliance to route through AWS Direct Connect. AWS Direct Connect provides access through a private VIF into the private subnets of your VPC. If you go from Direct Connect down, we're using a public VIF, which allows us to connect to the public services of AWS. And so through Direct Connect, we can create a network connection both to the private side of your VPC and private subnets, as well as the public side of public services that Amazon provides that are in our AWS region. Okay, so this is sort of the quick version of what VMware Cloud on AWS looks like, and I want to dive into kind of how it works and go a little bit deeper than these diagrams. So let's talk about operating in a hybrid ecosystem. And I've got a couple examples. So if you want to operate, so what I'm by hybrid in this case, what I mean is you have some things that you're running on the VMware side and some things that you're running on the AWS side. And I'll go through a number of examples of what those kinds of things might be. So the first example is you're running an application on premises that you would like to move up to the cloud. Maybe you want to maybe you're in the process of contracting your data center, and you'd like to slow down your purchase of hardware in your data center and start moving to cloud. And you have applications that are currently on-prem and you'd like to move them to a cloud environment. So XVMotion, using cross-account ENIs and using XVMotion, the same vMotion that you're used to using on-prem, is what will allow you to move a virtual machine from your data center to the right side of the previous diagram, VMware Cloud on AWS. Another example, you may want to copy an object from a virtual machine on the VMware Cloud side to an Amazon S3 bucket. And I'll talk about and show you a diagram of how we do that. You may want to connect to a data warehouse. You may want to connect a virtual machine that's running on the VMware side and take advantage of Amazon Redshift as a data warehouse. So I'll show a quick diagram of how we accomplish that. And lastly, I want to talk about how a virtual machine or an application which is outside of this environment can connect to VMware Cloud using the public internet. And so I think these 4 use cases cover an awful lot of the scenarios that people are interested in with VMware Cloud on AWS. And by the way, I'm going to kind of tie this all together. This is sort of the diagram, diagram architecture view, and I'm going to go through this very specifically with SharePoint as an example. Okay, so let's take those 4 examples one after the other. So in the case of using XVMotion to move a virtual machine from on-premises to the VMware Cloud, if you take a look at the diagram on the left, this is a virtual machine that you have running on premises. It's running in your data center, and you've decided for whatever reason you want to bring over the operating system, the data volumes, over to VMware Cloud on the AWS side. So you'll identify the target, and you'll use XVMotion, and by identifying that the target is a different site within vCenter, the VMware Cloud on AWS is just simply a new site. And so vMotion works between on-prem and VMware Cloud on AWS. So that's sort of the simplest and easiest way to move workloads from on-prem to VMware Cloud. Okay, and let's talk about the next use case. Let's talk about if you have an object or maybe a file or a blob on the VMware Cloud side on the right that you'd like to store in an Amazon S3 bucket in the middle on the bottom of the diagram. So what we would do in this case is we would take an object that lives in the virtual machine on the right, that green square box, and the object is that little red dot. And what we want to do is we want to be able to store it and move it to Amazon S3. So the way we do that is we create a path that goes through the VMware Cloud Elastic Network Interface, and that Elastic Network Interface acts as an endpoint, and that's where we provide firewall rules and ACLs. And so, from a VMware Cloud application, you're able to directly target Amazon S3 as a service through the Amazon VPC endpoint for S3. Okay, and Amazon S3 thinks that it's receiving an object from just a regular Amazon network. There's no NATing involved. There's no special routing involved. This is, as long as you go through the VMware Cloud ENI, that becomes a routing target, and the target can be this VPC endpoint, which in turn gives us routing directly to S3. And by the way, it's the same architecture and approach if we're using DynamoDB or if we're using any of the other public services that we make available in AWS. Okay, so let's take the third example I mentioned. Let's take Redshift. Let's say that you want to do data warehousing using Redshift. You want to take a virtual machine that's generating a lot of data, and you want to be able to analyze it in Redshift, which lives in the AWS side of the architecture. So what you would do in this case is we want to connect the virtual machine we want to connect the virtual machine on the right to Redshift on the left, and the network path is approximately the same. In this case, we don't need to go through a VPC endpoint because Redshift doesn't live in a public address space of AWS. We can just directly target, a VM can just directly target Redshift in this diagram. So there's kind of easy connectivity if you have a connection string to just point to what is the target destination as defined by a connection string using a DNS name resolution, or you could use a direct IP, and that's handled. Those translations are handled between the VMware side and the AWS side. I don't think I said it explicitly, but when we set up in the very beginning, when we set up the VMware Cloud VPC, it will have typically a different CIDR range, a different network address range than what your AWS VPC will have. Or put another way, there's no requirement that you homogenize or normalize your VPC ranges and IPs between the two clouds. Okay, so that's the Redshift example, and let's take the last example of providing access to VMware Cloud from somewhere on the internet. So in this example, what we want to do is we want to connect a virtual machine that lives on the internet. So my green box is pointing at the internet, and this refers to a virtual machine that may be anywhere on the internet. And what we're going to do in this case is we're going to use the IGW to create a direct connection between anything on the internet. The key point in using the IGW is that we need to assign an elastic IP to the resource that we want to make available on the internet. So just like you would in a VPC today and expose an instance or a resource to the public internet, we assign an elastic IP, and the target for the elastic IP can be either in the AWS VPC or in the VMware Cloud VPC. Okay, and when we do that, then we establish connectivity from the IGW through an internal routing mechanism that ultimately passes through the VMware Cloud ENI. The VMware Cloud ENI is what applies firewall rules. You can think of this as analogous to security groups in the Amazon world. And if security rules allow, then you're addressing your VMware virtual machine using a public IP address. Okay, so this has been kind of the really quick sort of diagrammatic tour of what VMware Cloud on AWS is. There's a couple pieces that are really important to be aware of. One is that the VMware Cloud transit endpoints all reside in the customer VPC. And so neither VMware nor AWS is in any way controlling the network access and network policy that you have around network interconnectivity. You continue to use security groups on the AWS side. So from the VMware side, if you're addressing an instance on the AWS side, you would continue to use security groups. From the AWS side, the way that you would know, or the way that you would target a virtual machine on the VMware side is we make available this ENI. We expose an endpoint that is very similar to a VGW. And so if you want to target an endpoint in the VMware Cloud VPC, which has a different address space than your private VPCs, you just in the same way that you would use a VGW to say, I want to target on-premise address spaces, you would use the same construct to target VMware VMs. Okay, and so that's my second bullet, that you as a customer maintain full security control over the transit path. On the VMware side, going out, you have VMware firewall rules. On the AWS side, protecting ingress, you have AWS security groups. And not only security groups, but you have NACLs to protect subnets, and you'll create flow logs for logging and being able to look at all packets that come in and out, and all network features that are part of VPC. Now, for those of you who didn't see the announcement, it was only about 2 weeks ago that VMware announced vSphere and vCenter 6.5. So these offer a number of new capabilities, starting with vCenter 6.5. vMotion traffic is encrypted. The VM itself is encrypted. There's a much deeper set of logging that's built in. And everything on the VMware side is provided by VMware. So it is VMware. It's not it's not anything other than VMware. The VMware side is provided by VMware, and I'll just mention that your relationship in procuring the VMware Cloud on AWS is through VMware. It's not through AWS. We host it with global infrastructure, and we provide these means of interconnectivity. But the actual offering is a VMware offering, and as a VMware offering, they provide the infrastructure patching. They upgrade all those. They upgrade vSAN, NSX, vSphere, vCenter. So they'll upgrade and patch all of their components. Okay, now I want to kind of sort of take this from the architectural level to an actual example, and walk through what an actual example would look like. And like I said at the beginning, I decided that I thought SharePoint would probably be a pretty good example. So this diagram is what we normally show and talk about when we want to talk about SharePoint running on Amazon Web Services. No VMware involved whatsoever. And this diagram is showing the usual organization in which users who live on the internet on the far left would access an internet gateway. An internet gateway would allow traffic to come in that would hit an elastic load balancer or an application load balancer, and that would distribute traffic across two availability zones, providing high availability in the event that either availability zone has a hiccup. This also provides a higher level of scalability. And for the actual SharePoint architecture, what sort of the canonical representation of SharePoint is, let's divide it into each tier of the application and provide private addressing and security controls for the web tier, app tier, database tier, and Active Directory tier. And if you've got really good eyesight, you can see how you can see the CIDR ranges that we've used to divide up, to carve up the VPC that makes up this architecture. And there's the other Microsoft infrastructures in there as well, like remote desktop gateways, the NAT gateway as a service that we provide. I haven't shown in this diagram connectivity to on-premises, but that would use Direct Connect, just like you would typically connect to on premises. Okay, so this is sort of the min role traditional topology of SharePoint. Now, how would we do this differently on VMware Cloud on AWS? So this is the overall flow, and I'm going to walk you through I'm going to build up this overall flow, but just as a roadmap for where we're headed. The process it can be basically thought of as, what am I going to do on the VMware side? What should I do on the VMware Cloud on AWS side? And what should I do on the AWS customer VPC side? So starting at the top left, we're going to start off with adding the components to VMware Cloud. And I'll talk sort of at the end about why I'm putting certain pieces on VMware Cloud and other pieces on AWS. But we'll start off by, if you don't have it, by provisioning VMware Cloud and AWS in the first place. I'm sort of, for this presentation, for this talk, I'm assuming that VMware Cloud is already stood up. And then once VMware Cloud is provisioned, you would carve up your VPC into subnets. You would create your firewall rules. You would define your overall IP ranges, and you would get your basic networking infrastructure in place. Then you would set up sort of basic interconnectivity, and I'll show you Direct Connect and VPN and how those pieces would come into play. Then we want to sort of pop up and make sure that we have all the Microsoft pieces. So I'm going to put Active Directory, which includes DNS and routing, onto the VMware Cloud side. And I'm going to put SQL Server on the VMware Cloud side, which will take advantage of Active Directory, DNS, and routing. So the top half of this diagram is really the VMware Cloud side of things. And if we continue from the bottom left to the right, then we'll sort of fill in SharePoint. Basically, I'm going to put the web front ends and SharePoint application servers in the AWS VPC. First, I've got to do some networking. Let's identify those subnets that I listed on the previous screen. You lay down the subnets, you lay down the routing, you set up the internet gateway, you set up either your own NAT instances or use our NAT service, kind of the basic plumbing on the left. Then we'll add Microsoft technology to the AWS side, Remote Desktop Gateway, and AWS Directory Service as a way to project AD from VMware Cloud. I'll talk about this more, how AWS Directory Service provides AD. We'll install SharePoint once we've laid down the structure and network connectivity of the solution. We'll install SharePoint, and we can use sort of any of the architectural design patterns of SharePoint. It doesn't matter if you're using, like my previous diagram, the traditional streamlined topology, or the SharePoint 2016 MinRole. All of them are equally fine in this architecture. And then the last sort of part of the puzzle are some of the things that I was showing on my last few slides of VMware Cloud, how we will integrate SharePoint with S3, Amazon Workspaces, Elastic Load Balancers, Application Load Balancers, CloudFront. You could use Elasticache. You could do log analysis with Redshift. So any of the cloud services that are available on the AWS side, you could then attach to a SharePoint architecture. So this is sort of the roadmap, and what I want to do is kind of walk through how we would set this up, and I'll come back to sort of the why piece once I've walked through the basic building blocks. So this picture is meant to be the unadorned version of VMware Cloud on AWS. There's nothing running here. What you see on the right represents, where I say Amazon EC2 on the right, that really represents this minimum of 4 host machines, and represents the storage that comes with those host machines, and represents the basic ESXi infrastructure to support those virtual machines. And if you can read the very small NSX blue dot, we have a software-defined network that's sort of integrated with ESXi. So this is just essentially nothing but VMware Cloud on AWS on the left. The first thing I'm doing is I'm putting Active Directory on the right side of the diagram, actually the reason I'm doing that is because every customer that I know has Active Directory on premises, and it's very easy to extend, or whether you're extending Active Directory or replicating it or federating it, it's very easy to get Active Directory into VMware. VMware has been doing this for more than a decade. And so the easy thing to do is, if you're running Active Directory on VMware today, to put Active Directory on VMware Cloud on AWS. Okay, and that's and you can vMotion that, or you can just create a new virtual machine, and with a new virtual machine, either from a template or from scratch, you can install the Active Directory domain services roles and features. Okay, so the next step is, okay, let's lay down SQL Server. And VMware Cloud on AWS is really strong in storage features. It's got really high performance. It's got NVMe storage, high performance SSD storage. It's got a lot of it. And so the storage architecture, running SQL Server on VMware Cloud on AWS runs in a really high performant way. And the vSAN piece of VMware Cloud on AWS supports a whole range of storage or high availability options, some of which aren't available or aren't easily available on the AWS side. So let me sort of give two examples. The example on my slide here is just setting up SQL always on between two nodes, two SQL Server nodes, a primary and a secondary on the VMware Cloud side. This works the same way that it works on premises. You set up listeners, and there's a witness that detects whether a node is down, and if the node is down, it sort of updates the DNS records of the listener to point to the node that it has continued to survive. Nothing is different about always on. On the VMware Cloud on AWS side, you can also support other technologies, for example, technologies that require shared storage, like failover cluster instances. So there's a lot of great technology for the storage subsystem. You can also support sort of previous technologies like mirroring and log shipping. But the two that are sort of considered the gold standard, if I may be so bold, are always on availability groups and failover cluster instances, which run well on VMware Cloud. Okay, so that's the VMware side, or a skeleton of the VMware side. And now let's set up SharePoint on the AWS customer VPC. So the first thing we do is we've linked these two accounts, and the way we've linked the two accounts is by using this technology that we're calling VMware Cloud ENIs, Elastic Network Interfaces. This technology is the same technology, is a similar technology to what we use in a current VPC, where an ENI allows you to set up, for example, a network interface and a set of security groups in one subnet of a VPC, and the same ENI can be stretched and support network interfaces and security groups in another subnet of the same VPC. What we're showing in this case is an extension of that ENI technology, in which we're actually providing cross-account ENIs. And so the way we're linking these two accounts is through an ENI in which an ENI is straddling these two accounts, because the VMware Cloud VPC is running in a VMware provisioned account on your behalf, and your account is your own account. So we're actually connecting the two VPCs over ENIs cross-account. So that's what provides the linking technology. And the next thing that I would do for SharePoint is I would stand up AWS Directory Service. The reason why is AWS Directory Service simplifies and abstracts and reduces some of the undifferentiated heavy lifting of managing Active Directory. AWS Directory Service runs Active Directory. It actually it provides Active Directory as a service, but behind the curtain, if you will, are actual instances of Windows Server 2012 R2. So we're running actual domain controllers, but we're managing them as AWS and we're providing IP addresses that your instances in the VPC can connect to. It's just you don't have to manage the actual domain controllers. we're backing them up. We're setting up replication. If there's a failure, we have automatic host replacement. So we're taking a domain controller on the VMware Cloud side, and we're saying, yeah, you can have that support the same users, groups, and computer objects on the AWS side, and we're going to provide it as a managed service. Okay, so once we have Active Directory on the AWS side, then we can keep going, and we can add a little more of the sort of basic plumbing. So we'll add remote desktop gateways on the left DMZ subnets, and this is for sort of traditional RDPing into the private subnets. You can use these as jump boxes for remote PowerShell. And we have a NAT gateway so that the private subnets that you see listed there, the instances that live in those private subnets can use our NAT gateway service to connect out through the IGW to the internet. Okay, so let me go ahead and fill in the SharePoint servers. So at this point, I have all the infrastructure I need. I have Active Directory. I've got SQL Server. I've got connectivity from inside either VMware Cloud or AWS to the internet, and through the internet gateway, users can come in from the left and access a SharePoint environment. Okay, so this is the majority of the solution, and then if you remember my roadmap slide, there's some other pixie dust that we can sprinkle on this solution to make the overall solution a little better. So one quick piece of, it's not really pixie dust, but another piece of infrastructure is we'll add the elastic load balancer so that when user traffic comes in, it's distributed across the 2 availability zones. I also, at the same time, I added the Amazon S3 bucket, so that one of the technologies that works really well with SharePoint is RBS, remote blob storage, where you can take files out of SharePoint and store them, for example, in an S3 bucket. And so this is, in my example previously where I showed how you would create connectivity, we can do this with SharePoint and store, typically Microsoft recommends that you store large blobs. Instead of in SQL Server, you externalize them to an object store or a file system. So in this case, we would use a remote blob store technology in SharePoint and store blobs in an S3 bucket. There's other interesting things you can do as well, like archive content that hasn't been accessed for 2 years and treat S3 as the storage instead of SQL Server, because the cost of an S3 the S3 service is lower than the cost of EBS. Okay, and lastly, I've added Amazon Workspaces to provide an alternative to user desktops. This is a hosted desktop, and it gives users access to the environment here. So just a few examples of adding Amazon services to what would otherwise be a vanilla SharePoint architecture. Okay, and there's a sort of a couple points that I would make about this overall diagram. The first one is around Active Directory, and I tend to think of Active Directory in VMware Cloud as an extension of on-premises AD that you're extending to AWS. And so all of the things that you would need to do with Active Directory, if you were doing it on premises or if you were wherever you're doing native Active Directory, you would need to configure AD sites and services. This is important because you have to still take into account your sites and subnets and site link costs and configure all that for an AD architecture. You actually have multiple options for integrating with AWS Directory Service. So there are other talks here at reInvent that go into the details of, in my case, I have extended Active Directory from VMware Cloud directly to the AWS Directory Service, but you can also take advantage of trust relationships, one-way trust relationships, two-way trust relationships. You could put a subdomain on the AWS side and a second two-level domain on the VMware Cloud side. You can use ADFS for federation. You can use third-party tools. So there's actually a huge number of options for connecting Active Directory kind of classic Active Directory to the AWS Directory Service. Then the sort of next point is SQL Server. And I mentioned that SQL Server has great storage capabilities and is a very well-known workload in the VMware world. So provisioning SQL Server on VMware Cloud gives you a number of capabilities that make it easy to migrate to the cloud and make the cloud sort of an easier next step. So using vMotion, like my diagram in the very beginning showed, you can move SQL Server, the operating system of SQL Server and the SQL Server data volumes. You can just lift and shift SQL Server directly to VMware Cloud on AWS. And it's an option that makes that a little bit easier. There are other sessions that talk about how you might want to migrate SQL Server to AWS. There's a whole range of options. There's a database migration service. There's an AWS Snowball service. There's just simply backup and restore. There's Direct Connect to just replicate databases directly. There's always-on availability groups that span AWS and on-premises. So there's actually lots of ways to move SQL Server. vMotion is probably one of the most straightforward ways to do this. And most VMware customers are knowledgeable and proficient in. I mean, they've been using vMotion for a long time. So on the SQL Server side, I mentioned that you have a couple options for high availability, whether it's always on availability groups or failover cluster instances, or mirroring or log shipping. All that works. What I didn't show, which is an interesting option, is you can provide high availability between the VMware Cloud side and the AWS side. So you could set up an always-on availability group in which the primary lives on the VMware Cloud side and your secondary lives on the AWS customer VPC side. So a reason for doing this would be if you're concerned about the availability of, if you're concerned about the entire account or the entire VPC on either side, either the Amazon side or the VMware side, being a single point of failure, you can have an availability group spanning both sides. Okay, and we're not really talking about speeds and feeds and performance of the service right now. But if you're in the beta program, you'll be able to test performance. And because the infrastructure of VMware and our infrastructure runs in the same data centers, I can tell you that the performance feels, it feels like you're on a LAN. The whole vMotion thing would only work if you had high bandwidth and low latency. Okay, and I configured the SharePoint roles on the customer VPC to point to SQL Server. That's an easy thing to do. It's easy to set up SharePoint roles on the AWS customer side. I could have done it on the VMware side, but I wanted to sort of divide up the architecture. We have CloudFormation templates that allow you to deploy these SharePoint roles, and so you can use a template if you want to just make that part of the architecture very, very simple. And then there were a couple pieces that I said were new, and let's try clicking again. And so one of the pieces that's new is using Amazon Workspaces to provision cloud users. And if you provision Amazon Workspaces, you get these hosted desktops who use the Active Directory services from AWS Directory Service to connect with VMware Cloud, or even connect with on-premises if you have two-way trusts. So Amazon Workspaces is just a way to enhance the solution. You can also, like my example a minute ago, you can use Amazon S3 to support to be a target for remote blob storage for SharePoint documents. So now I wanted to go into kind of a quick demo of this whole thing and show you what it actually looks like. So let me switch machines here. Okay, and on my demo laptop, the first thing I'm going to do is I'm just going to log into AWS, and I'm logging into an AWS account that's already linked to the VMware Cloud account. Hello. Okay, and so this is just AWS. You won't see a VMware Cloud service on the AWS side. If you look at all the services, you won't see VMware Cloud in here because, like I said at the very beginning, this is a service you would get directly through VMware. But if we jump into the VPC, or if we jump into EC2, and let's take a look at just the instances that I've created on the EC2 side. I don't have a huge number of servers here, but I've got a SharePoint deployment that gives me, I think, 8 SharePoint web front ends, and server number 6 happens to be deployed as a SharePoint application server. My remote desktop gateway. I've put a domain controller on the AWS side, as well as AWS Directory Services. You actually don't need to do both. And on the VMware side, so if I want to take a look at what does this look like on the VMware side, I'll log into VMware Cloud Services. And what this is bringing up for me is the environment for vCenter. Okay, and I've actually got vCenter already opened over here. And what I want to show you on this side is that if you remember my architectural diagram, I only had the 2 SQL nodes, SQL Node 1 and SQL Node 2, as well as the quote-unquote on-prem Active Directory. So for my demo 4, I really only have 3 virtual machines that I'm running in this environment. And if I want to take a look at any of those machines, I can use vCenter capabilities. So in this case, I'm going to just launch their web console for Active Directory. And we'll go ahead and log in. Okay, and this is the domain controller that's running as an ESXi virtual machine, and all the sort of usual things that you would expect. You know, this isn't meant to be a session really of Active Directory. This isn't a drill down on the Microsoft stuff. I've got 10,000 users. I've got a set of computers. You can see the VMware side, because we've got Active Directory, I've also got DNS, and so you can see, I can bring up DNS directly. You know, nothing, if you've been working in the Microsoft world, none of this is new. This is all just you know, garden variety Active Directory that you've been using for a long time. And I can see things like my SharePoint web front end server. You know, I've got its A record and its PTR records, and I'll just bring up one final thing. Active Directory sites and services, and you'll be able to see that what we've done. I didn't cover this. This is actually covered more in the drill down AD sessions, but we've divided each subnet of each VPC into its own site for routing reasons. And then you can use site link costs to define the logical costs of sending domain traffic from one subnet to another. So, of course, the logical cost is going to be much greater to have a member server or a workstation authenticate a cross direct connect to a virtual machine either on the VMware side or on the AWS side. So you'll set up site link costs, and you know, so I've set up the subnets that I have here. The 192.168 network is the VMware network, and the two 172.16 networks are the AWS network. Okay, and you can see that I've got 3 sites, and I won't. So you can see this is like just, you know, regular garden variety Active Directory. I don't really, just in the interest of time, I'm not going to, I just want to show you that SQL Server is up and running. Let me go back to vSphere here, and we'll go to our primary node and launch the web console. And what's interesting is, I guess I should have maybe said this earlier. What's interesting is once you've set up the basic plumbing, the network infrastructure for what's happening on VMware and AWS, at that point you're living in the Microsoft world. So I'm logging in here to SQL Server, and I'm not doing anything with VPCs and route tables and endpoints and direct connects and any, you know, this is at this point, this is, you know, SSMS is just SQL Server, and it just happens to be running on ESX. So let me sort of, you'll see this. You'll see it's, you know, garden variety SQL Server. If you're familiar with the sort of database layout of SharePoint, you can see it all here. So let's now switch over to what we have running on the AWS side, and I want to show you the interconnectivity. So on the AWS side, I showed you the instances before. If you didn't catch it, I don't have the 3 machines that I showed you on the VMware side. So you don't see SQL N1, SQL N2, and you don't see SQL AD because those are running, you know, those are tossed over the wall. But you do see all the other machines that I have here. And let's just connect through our gateway and take a look at our environment from inside of AWS. I've already connected this environment, so I may not. Well, I can go ahead and log in again. Whoa. I was already connected, so I guess I had hit my connection limit. Okay, so what I have running here on the left side is this utility, Remote Desktop Connection Manager, and this allows me to take a look at all the virtual machines that make up both environments, and I'm using this particular utility because since I have network connectivity to both sides, at this point I can also click on a virtual machine by IP address. By the way, this happens to be the SQL box, SQL N1 box. I can connect to the SQL N2 box. I can connect to SQL AD, which is the authoritative Active Directory that I just showed you a second ago. That's actually the secondary, I guess. And I can connect to the primary as well, node 1 and node 2. Okay, so that's the entire environment. And from a SharePoint perspective, so, you know, sort of ultra basic stuff. I mean, just to show that it works, I've set up just the template for a portal, the template for a blog, the template for a team site. No customization, just to sort of wire everything up. SharePoint Central Admin. You can take a look at everything that's in the farm. You can see all the different SharePoint roles. I mentioned earlier that SharePoint role 6 is an application role, so I can load things like search and other application services onto that role. And now, where things actually get interesting is, so this is just basic SharePoint. You've seen basic AD. Now let me add sort of the cloud aspects of it. So the first cloud aspect of it is, I'm going to open up Elastic Load Balancing in the cloud, ELB in the console, because I want to show you the Elastic Load Balancer, and then we'll access SharePoint through the ELB instead of just going through each individual instance. Come on, ELB, you can load. So ELB will in fact load. There we go. And what I've configured for Elastic Load Balance, the Elastic Load Balancer here is a load balancer that's sending traffic to my 3 subnets on the AWS side. to US West 2A, 2B, and 2C out of Portland. I've got the DNS name, which is going to resolve to my instances, and let me just show you. We're sort of coming towards the end, but if I access my portal through the ELB, take a look at. Let's go ahead and provide the user and the password. Okay, and if you look very carefully at the top here, what you're seeing is that I'm accessing my SharePoint, one of the SharePoint web front ends through internal-dl demo4 ELB, and I'm trying to resolve this page. Let's just hit F5 here, I guess. This is supposed to resolve. While this is resolving, I'll maybe come back to that. Let's go ahead and take a look at the AWS. Oh, it still is loading the page. Let's go ahead and load the AWS Directory Service, which is providing the managed AD side on the AWS side. And AWS Directory Service, open in a new tab. I don't see the new tab popping up. Sorry? Yeah, maybe I'll do it in a new window. Not sure what's happening with Internet Explorer. Maybe I'll try it from just another one of my boxes. So if we just want to bring up or I can do it directly from the console. So if I want to open up AWS, okay, now it looks like it's at least trying to open. Let's see. I'm going to go to the console because I think doing this out of I'm not sure if we're losing network connectivity or what's happening here. But just to give it another shot, let's go. I'm outside of the remote desktop environment, and let's go directly to AWS Directory Service. Okay, that's a little better. And there's my directory. And what my directory is it's a demo that's providing directory services across two of my subnets in my customer VPC. And if I click on the directory, you'll be able to see that I'm connected to SQL-dom.local, the name of my directory. I'm using managed AD to support this AD as a service capability. Again, you can see the subnets that are being supported, and because I'm using AWS Directory Service, I have support for these alternative services that are only cloud-based, like workspaces and work docs. Okay, and I don't know if you caught it when I was showing Active Directory users and computers. I think we have 10,000 users in this directory. Okay, so that's AWS Directory, and let's see if the load balancer is working. I don't know why before that didn't come up. Do I already have that? Let's just jump down to my load balancer. Okay, and here's my load balancer, and let's grab the DNS name of my load balancer, because what users are going to be doing, I've actually set up an internal load balancer, so I should use this from inside my VPC. And if the directory did finally come up, and so let's access SharePoint now through my load balancer. And you can see I'm hitting one of my instances, and it's pulling up my portal. And every time I hit refresh, it's it's generating another one of those sites through one of those 7 or 8 SharePoint web front ends or the single SharePoint application server. Okay, so there you have it, VMware Cloud on AWS. I guess I just want to close with the interesting thing to me is the fact that we make it very easy to get VMware virtual machines and technology, and we let you use the skills you have to use that knowledge on AWS. We provide a high-performance version of VMware Cloud on AWS. And then you can use VMware where it provides things that are best of breed, so things like vSAN storage. And I didn't, other sessions have talked about things like tunneling layer 2 encapsulated inside of layer TCP/IP layer 3. So there are there are scenarios that VMware supports that we don't support that we now can provide in an integrated cloud environment. And conversely, being able to use things like AWS Directory Service and workspaces and load balancer, our load balancer provides additional pixie dust and capabilities that enhance solutions that may have a piece of it running in VMware. So we're very excited about this offering, and thank you for joining the session today.